In this module, we'll discuss the goals of your automation project, the types of tests you should prioritize automating, what to expect from your automation journey, how to write an effective test plan, and how to develop maintainable automation. Before you start, it's important to consider what you want to get out of an automation project. You may want to save time by reducing time spent on manual testing. You may be looking to use your lab resources more effectively by using automation to run tests 24/7. You may be focused on test accuracy, ensuring that tests are identical on each run. You may be looking to increase your test coverage, using time and resource savings to add more tests to your test plan. The most obvious way to get bang for your buck from automation is to automate the things you need to do most often. Outside of that, how should you prioritize? Not all tests are good candidates for automation, especially as you start off on your automation journey. You may be tempted to tackle complex test cases because those are the most painful to run manually. However, starting with the simplest test cases, especially while you're learning, is the quickest way to success. While automating these simple tests, you'll be building your library of reusable assets, which in turn will make your complex tests easier to automate. You may never get to the fourth quadrant shown in this graphic, as some tests just aren't worth the effort to automate. This J-curve represents a typical automation journey. Productivity, the number of tests run, for example, will drop when automation starts. We call this the valley of death. Don't despair. This training will aim to pull you through that as quickly as possible. On the other side, as you start to get over the learning curve and get a small library of reusable assets and completed tests under your belt, you'll start to reap the benefits. Before you start to automate anything, you need to be sure to understand what exactly your test should accomplish. Broadly, test plans should define the steps needed to run the test and describe the conditions or measurements needed to declare the test as a pass or a fail. They should be detailed, meaning they completely describe the steps needed and the pass-fail criteria. They should also be definitive, meaning all needed steps and pass-fail criteria are included and only needed steps and pass-fail criteria are included. Start by analyzing the product. Consider the purpose of the end product. Walk through typical use cases and identify common failure points. Next, you should develop a test strategy. Why are you running this test? Are you testing a feature, load testing, security testing, testing a specific bug fix? Answers to these questions will help you define your pass-fail criteria. A list of conditions required to consider the test a pass, as well as any known failure states. And finally, we'll detail the procedure. So here you want to create a detailed, repeatable, step-by-step process to execute the test. This is where you'll note the commands that you need to use to configure the device and to trigger any events that might be necessary for the test to run. For our first hands-on lab exercise, we're going to write a test plan together. In this case, our device under test is a Juniper switch. We're going to do a feature test on the port admin commands. So basically, we want to make sure that the ports go up and down when we shut them down or re-enable them. So let's start writing this test plan document. First, we're going to want a title. We'll call this our L2 switch test plan. This is going to apply to all the layer 2 switches in our theoretical lab. And in this particular instance, it's for a Juniper switch running this version of firmware. And that version of firmware is important just because we're going to be showing real responses from the device here in the test plan. So we want to just note that this is where they came from. So first, let's give our individual test case here a title. So we'll call it test case 1. This is the port administration test. So the best way to start is to write a summary, just kind of a high-level overview of what you expect the test to do. So in this test, it's a feature test of our port admin commands. We're going to test that when the ports are enabled and disabled, the port summary information is updated correctly. Now we want to define our pass-fail criteria. So we have two in this test. The first one being that when a port is disabled, the port summary information will show the port is down, and the second being that when a port is enabled, the port summary information will show the port is up. You may have some prerequisites to your device or to your test bed, your lab environment, that you need to make sure are in place before you can run the test. Let's define those before we define our actual test case steps. Here we have our first prereq. We're going to make sure that we're running the expected firmware, the firmware that we want to test. We're going to be running this test against different versions of firmware throughout the switch's lifespan. So just do a quick check to make sure we are testing the version that we want to be testing. And then for the second prereq, we want to make sure that the interface that we are checking, we're going to call the primary interface, is already up, because you can't really shut down an interface that's already shut down. So notice that each of these prereqs has 3 rows. The first one being the commands that are needed to do the check. The second one being the pass-fail criteria that we're checking. We're just defining what needs to be seen in the prereq for that prereq to pass. And then we have expected output, so a nice readout from the device as to what can be expected, whether you're doing this manually or in automation. So next, let's go ahead and define our procedure. The first step, we're going to ensure that the primary interface is shown as down after disabling the interface, and that lines up exactly with our first pass-fail criteria. We have a sub-step here, and just a list of the commands that are needed to do that sub-step. So in this case, we're disabling the interface. There's no pass-fail criteria here because there's no output. We're not expecting to see anything from the device when we do these commands. But in our next sub-step, we see that we're doing this show command to check that the interface is actually showing up as down. So we have our pass-fail criteria listed. We want to see that the admin status is disabled and the physical status is down, and we have the expected output from the device that shows that. Step 2 is going to look very similar to step 1. We have a description of the step here. Ensure that the primary interface is shown as up after enabling the interface, which lines up with our second pass-fail criteria. We have a couple sub-steps. The first, where we actually enable the interface. The second, where we check that the interface is showing as up with our show command. Again, we have the pass-fail criteria listed out here, and we have the expected output shown. Now our test document has everything you need to run the test manually or to build an automation script. And anyone that comes across your test results or your automation that you create later on can refer to the document and know exactly what's going to happen in that test and what they should expect to see. Now we've laid the groundwork to create a single test, but we're going to want to create much more than that. So we're going to think a little bit about the project as a whole and how we can develop maintainable automation. Single-use automation is unsustainable. Start thinking about maintainability from the start. Remember, a big goal of automation is to increase efficiency and save time. Your automation should be portable. Make sure you can reuse your automation to test different firmware versions, physical devices, different vendors, etc. It should be modular. Make sure you can reuse pieces of your work throughout your automation efforts. And it should be environment agnostic. Build your automation so that it can live through changes to your lab.